Okay, let's look at the practice problems from the last day. They were page 593, numbers 2 to 6. So number 2 says a mercury atom drops from 8.82 electron volts to 6.67 electron volts above the ground state. So the initial is 8.82 electron volts. And E final is 6.67 electron volts. And the question part A wants to know what is the energy the photon emitted. So we know from Bohr's equations that EP is equal to the final minus the initial. So EP is equal to final 6.67 electron volts minus initial 8.82 electron volts. EP is equal to negative 2.15 electron volts, where the negative means emitted. That's part A. Part B wants to know what is the frequency of the photon. So then you would do EP equals HF. So F equals EP divided by H. And you can drop your negative now because all that negative over there meant was emitted. So we don't need to carry it when we're looking for the frequency. So 2.15 electron volts, we have to change it to joules. So 1.602 to the negative 19 joule seconds divided by 6.626 joules. This is per electron volt, sorry. 6.626 times 10 to the negative 34. This one's joule seconds. And when you do this, you get a frequency of 5.198 times 10 to the 14th hertz. Okay, so that's number 2. Now the next line in the book says, see figure 2823 for problems 3, 4, and 5. 3, 4, and 5, and 2 actually, have to do with the mercury atom. So if they're going to use any atom other than hydrogen, they're going to have to give you this. They're going to have to give you the different energy levels with the energies. And usually we use the negatives. Now that one just used the positives. And if you look, they're exactly the same, right? E1 on the negative side is the lowest possible energy, and so it's negative 10.38. Where on the other side, they're saying, okay, let's call that 0 and go up. Well, these also go up. So this goes from negative 10.38 up to 0. This one goes to 0, from 0 to positive 10.38. So it doesn't matter which side you use here for mercury, you'll end up with the same numbers. I tend to use the negative because in hydrogen we have that equation En equals negative 13.6 over n squared, so we'll always have negatives for the E's. So if it's not hydrogen, they're going to have to give you this diagram when you're trying to find the photons, the energy of the photons emitted. I don't have to give you this diagram for hydrogen because you can figure them out yourself by doing E equals negative 13.6 electron volts over n squared and filling in 1 for n, 2 for n, 3 for n. Okay, so these next 3 questions are using that mercury diagram. So number 3 says, a mercury atom is in an excited state when its energy level is, so E is equal to 6.67 electron volts above the ground state. A photon of energy 2.15 electron volts strikes the mercury atom and is absorbed. So this is going to be an I. It's where you're starting. And EP is 2.15 electron volts, and it's going to be absorbed. So it wants to know to what energy level was the mercury atom raised. So you're doing EP is equal to final minus initial, and this time you're looking for final, so take the initial over, EP plus E initial. So EP 2.15 electron volts plus 6.67 electron volts. These numbers seem awfully familiar. EP is equal to 8.82 electron volts, and it wants to know to what level, to what actual number level, like what's the n. So then you have to go back to this chart and you have to find the 8.82, and there it is, second from the top, you go over and you say, oh, that's 9. So it's raised to n equals 9. Okay? Number 4 says, a mercury atom is in an excited state at the E6 level. So you can look on your chart and find out what E6 is. And I'm going to use the negatives just because we've been using the positives, 2.68 electron volts. And then it says how much energy would be needed to ionize it. So on the negative side, the ionization energy is 0, right? See it at the very top there? Except it's not very clear. There we go, the ionization, so E final is going to be 0, okay? Now it's not clear here because I keep moving it around. There we go. So E final is 0. And it wants to know, so how much energy would, like what's the E photon? So final minus initial. So EP is equal to 0 minus a minus 2.68. So the energy that it's needed, the energy of the photon that would be needed to ionize it is 2.68 electron volts. It's one of the reasons why I like the negative side, because whatever the energy of a particular level is, that's how much you need to ionize it. Just to take it up to 0, just drop the negative. There's a part B, how much energy would be released if the electron dropped down to the E2. So now you're doing EP equals E started at 6 and it's going to 2. So E2 minus E6. So EP is equal to, if you look at your chart, 2 is negative 5.74. And if you want, you can use the positive side. You'll get exactly the same thing. But you got to use the same side for both of them. So don't use the positive for one and the negative for the other. All right. Minus a minus is going to be a positive. But you're here and you end up with negative 3.06 electron volts. And of course, the negative again just means emit it. All right. Number 5. Says a mercury atom is in the excited state that has an energy of negative 4, so negative 4.95 electron volts. And it's going to be your initial because it says it absorbs a photon that raises it to the next energy level. So you need to take a look at your chart, and when you do, the negative 4.95 is E equal to 4. So this is 4. And so the next state is 5, and 5 is negative 3.71. And the question wants to know what is the energy of the photon. So EP is equal to EF minus EI. So EP is equal to, final was this one, so negative 3.71 minus a minus 4.95. So EP is equal to 1.24. It works out to be positive because it's absorbed. The B part of the question wants to know what is the frequency. So again, E equals HF. So F equals E over H. So 1.24, and you have to multiply it by the conversion, 1.062 to the negative 19 joules per electron volt. Divide by 6.626 to the negative 34 joules seconds, and you get a frequency of 2.998 to the 14th hertz. Number 6, a photon, EP, with an energy of 14 electron volts, enters a hydrogen atom in the ground state. Hydrogen atom at ground state, E1 is equal to negative 13.6 electron volts over N squared, which would be 1. So E1 is going to be negative 13.6 electron volts. Photon with energy of 14 volts enters a hydrogen atom in the ground state and ionizes it. With what kinetic energy will the electron be ejected? So you can do this two ways. You can do EP is equal to E final minus E initial. And you can find your E final, what's left over, right? So EP will plus EI, so 14 electron volts plus a negative 13.6, and you would get